All right, we're going to talk about linear equation, slopes, and applications. Okay. So the first thing is we're going to talk about horizontal lines. Horizontal lines are given by equations of the type y equals b or f of x equals b. They're called constants. Okay. These are functions. So these are going to be horizontal, right? Horizontal. The vertical line test, we'll go through them once. They're functions. Vertical lines are given by equations of the type x equals a. They are not functions, they are vertical lines. So the slope m of a line containing points x1, y1, and x2, y2 is given by m equals, and I'm sure most of you have heard, rise over run, equals y2 minus y1, or x2 minus x1. Now this one here is also it's equal to delta y over delta x, talking about change of y over change in x. Okay, so I kind of threw that in there. Some books kind of show it that way, some don't. I just wanted you to kind of see it. All right, so we're going to find the slope between these 2 points of 8,3 and negative 5,2. It does not matter which one you pick as x1, y1 or x2, y2. It just matters that you keep the order. So I'm going to go, okay, 3 minus 2 over 8 minus negative 5. 3 minus 2 is 1. 8 minus negative 5, so this turns into a positive. That gives me 13. So 1/13 is my slope here. Now, one of the important things is slope can also be considered as an average rate of change. So a lot of times if somebody's talking about average rate of change, they're talking about the slope. If they're talking about the slope, they're talking about the average rate of change. This has become a catchphrase, so if you see that terminology in a question or in a story problem, they want that to be the slope. Okay? So we're going to graph a couple of lines here. We're going to start off with x equals 2. Well, x equals 2, I go to where the x is 2. Okay, so right here. Well, x is always 2. I don't care what the value of y is. Y can be anything. But x has to be 2, so it's a vertical line. Now, if I come here, y equals negative 1, I go to negative 1 on the y-axis. Now, y has to stay as negative 1, but then the x can be anything we need it to be. So that becomes a horizontal line. So x equals vertical, y equals horizontal, function, not a function. Okay? All right, so that brings us to probably the most common form of a line. Y equals mx plus b. It's the one that if I say, hey, what's a line? Everybody shouts out y equals mx plus b. That's slope-intercept equation or slope-intercept form. M stands for the slope. B stands for the y-intercept. Okay? So where is this graph intersecting on the y-axis? So here's our equation. Y equals negative 2/3 x plus 4. I'm going to go ahead and graph that. I'm going to use my slope and my y-intercept. So I'm going to go ahead and plot the 4. First of all, so this gives me a 4 on the y-axis. So there's my intercept. I put a dot there. Now, when I'm doing this, I always put my sign to the top value. The reason I do that is it just makes it easier because a lot of times if I have students that are struggling, I can kind of just tell them, well, up or down and to the right, up and down and to the right. And so that way they know that this number on the bottom is how much they're going to the right. Yes, I know that you can flip it around and do some other stuff, but usually students that are struggling graphing, they can see that it's positive goes up, negative goes down, and so it just kind of helps them. So I'm going to go down 2, and then right 3. There's my second coordinate. I could continue to plot coordinates that way. Down 2, right 3, there's another coordinate, and I'm going to connect those. I'm going to draw my line in through those points. There's my graph. You really only need 2, but we did 3. The last thing we're going to do is we're going to convert to slope-intercept form. So here we're basically in standard form, and we're going to move it to where we only have a y on one side of the equation. So the first thing I need to do is get everything that's not a y to the other side. So I'm going to add my 7. I'm going to do this step by step. 3x minus 6y equals 7. I know many of you will probably shorten this and do just kind of one step, do all your addition and subtraction in one step. That's fine. I just wanted to make sure I kind of showed every single step. Okay, so I subtracted off my 3x. The last thing I need to do is divide by -6. So I'm going to divide by -6. And when I divide by -6, I have to divide every single term by -6. Very, very important. So then I get y equals, well, -3 over -6 is 1/2 x. Plus and a minus gives me -7/6. So I have my slope, I have my y-intercept. I have now converted to slope-intercept form. So that's linear functions, slopes, and applications. Is you're going to apply this to real world situations. Average rate of change is you're going to find the first entry, the last entry, find the slope, even though the graph may not be linear.